Welcome all of you dear friends. This is the simplest and easiest way of teaching learning process in our most popular YouTube channel. Physics Make It Simple by Dr. Rajendra Kobarne, now serving as a principal in Lokanete Dr. Bala Saheb Vikhe Patil, Padma Bhushan Awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalaya and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. Okay. As long as 12 Science Wave Optics is concerned, this is a lecture number 16, and in this lecture we want to study derivation of conditions for occurrence of bright and dark fringes on the screen. I have written this article in question form. The question is, read the question along with me. Derive the conditions for occurrence of bright and dark fringes on the screen. We have to derive the condition, and for that purpose I have taken P point on the screen. See here, this is a P point on the screen, and these S1 and S2 are the two coherent sources. They are very closer. Distance between two coherent sources is small d, and distance between two coherent sources and the screen is capital D. Remember well, capital D is very much greater than small d. That is most important thing. Capital D should be very much greater. So this distance should be greater and this distance should be smaller. So draw the ray diagram in such a way that it clearly indicates that distance between S1 and S2, that is small d, which is a smaller, and distance between two coherent sources and screen, capital D, should be larger. I have made labeling below the diagram. S1, S2, two coherent sources. Small d, that I have already told you. Distance between two coherent sources. Capital D is nothing but the distance between two coherent sources and screen. That is capital D. And what is Y? For that purpose, I have drawn two perpendicular lines shown by the dotted lines. Draw S1M and S2N. These two lines are perpendicular to the screen. This is OO dash. O dash is nothing but the center of the screen. If distance between S1 and S2 is small d, therefore distance between M O dash is definitely d by 2, and this distance is also d by 2. D by 2 plus d by 2, we get small d. And I have taken P point, which is at a distance y from where? From the center of the screen. So what explanation we write? I have not written explanation here. Consider two sources. Write down explanation in a simplest sentence. Small a, explanation. How we can write explanation? Consider two coherent sources S1 and S2 separated by a distance small d. Small b. Distance between two coherent sources and screen is capital D. Next line. Small d is very much smaller than capital D, or capital D is very much greater than small d. Okay. What is Y? Y is a distance of a given point from center of a screen, and we have to calculate path difference between two waves. This S1P is a first path, S2P is a second path from which the wave is propagating. This explanation is sufficient. Then path difference, this path is somewhat greater than this path, So we have to calculate a path S2P minus S1P. For that purpose, we will consider first triangle. Consider the triangle S1MP. Where is S1? S1MP. This triangle. S1MP like this. So we can write here S1P bracket square is equal to S1M bracket square plus MP bracket square. S1P square is equal to, what is S1M? S1M is capital D, D square, plus what is MP? MP. MP. This distance is Y from O point, O dash point. So MP is nothing but Y minus D by 2. So I have written here Y minus D by 2. By squaring, we get what here? D square as it is plus Y square plus square of this is D square by 4. Multiplication of 2 and twice, we get minus YD, equation number 1. Then similarly, consider the triangle what here? S2NP, this triangle, S2NP. So we get what? S2P bracket square is equal to S2N bracket square plus NP bracket square. NP, up to this it is Y, and from this to this D by 2. So we get plus here. Simplification of this, we get this equation, equation number 2. We want to calculate what here? We want to calculate S2P minus S1P. For that purpose, we do subtraction, equation 2 minus equation 1. We get what here? We get this equation like this. S2P square minus S1P square is equal to 2YD. How it gets? This D square will cancel with this D square. This Y square will cancel with this. D square by 4. This D square by 4 we get cancelled. Then here YD minus minus plus, we get 2YD here. And this is a simplification of what? A square minus B square is equal to A plus B into second bracket A minus B. So we get S2P plus S1P. S2P minus S1P is equal to 2YD. We want what here? Path difference. S2P minus S1P. S2P minus S1P we get is 2YD upon this term come here. S2P plus S1P. So what is S2P? This S2P is approximately equal to capital D, and this S1P is also approximately equal to capital D. So we get what? D plus D is equal to 2D. So path difference is denoted by delta L, which is equal to this 2 get cancelled, and we get YD upon capital D. This is a path difference between these two waves when it reaches up to point P. And we have to find whether that P point is bright or dark. That is our most important thing. So path difference, we have to calculate path difference at first, and that path difference delta L is equal to YD upon capital D. Small d is a distance between two coherent sources. Y is a distance between given point and center of the screen, and capital D is the distance between two coherent sources and screen. That is all labeling regarding this formula. In general, we can write what here? Instead of Y, we can write YN. YN means what? Nth bright band. Distance of the nth bright band. This YN is nothing but distance of the nth bright band from the center O dash of the screen. So condition for after calculating path difference YND upon capital D, now we have to discuss condition for constructive and destructive interference pattern. Constructive means P point is bright and destructive means P point is dark. So I have written here condition for constructive. So we get if delta L, that is path difference, if delta L is equal to n lambda, or I will multiply it by 2 and divide it by 2, 2n lambda by 2. This 2 get cancelled, we will get again n lambda. These two equations are similar. So path difference either n lambda or 2n lambda by 2. So here n starts from 0, plus 1, plus or minus 1, plus or minus 2, plus or minus 3. What this minus sign indicates? Plus or minus 1. This is first bright band, upward side. This is first bright band, downward. This is second bright band, upward. Second bright band, downward. So downward band is suggested by the number minus, and upward band is suggested by the number plus plus. And so that we can write here plus or minus, plus or minus, plus or minus. That is nothing but the number of bright bands on upper side of the screen, on the upper side of the center, as well as on the downward side of the center of the screen. That is plus or minus 1, plus or minus 2. And how we can state the condition? See here, if the path difference between two light waves is integral multiple of wavelength lambda, listen carefully. You should write this statement in your notebook. What is the condition of constructive interference pattern? Condition of constructive interference pattern is if the path difference between two light waves is equal to integral multiple of wavelength lambda, or path difference between two light waves is even multiple of half the wavelength. This is lambda by 2 is nothing but the half wavelength. 2n, put 1 here, we get 2. Put 0 here at first, 0, 0. Then 1, we get 2. Put 2 here, we get 4. Put 3 here, 3 into 2, 6. Put 4 here, 4 into 2, 8. That means we continuously get 0 lambda by 2, 2 lambda by 2, 4 lambda by 2, 6 lambda by 2, 8 lambda by 2, 10 lambda by 2. That means we get even multiple when the wavelength is half, or it is integral multiple when it is wavelength. So remember well, these two statements you should be very much clear as long as your competitive examination is concerned. If the path difference is either integral multiple of wavelength lambda, or if the path difference between two waves is even multiple of half the wavelength, where n starts from 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on, we get bright point. P point is bright point, so called as constructive interference. So this is all about in terms of path difference. That path difference is y&d upon capital D, that we denoted it by delta L. Then now second, condition for constructive interference in terms of phase difference. Remember well, dear students, while discussing about the phase difference is denoted by delta phi, and I will give you a simple trick to explain phase difference. Remember well, instead of lambda, write down 2 pi, because wave covers a distance equal to lambda after covering an angle 2 pi, and so that lambda corresponds to 2 pi. Wherever lambda is there, instead of lambda, put 2 pi. See here, instead of lambda, put 2 pi. Instead of lambda, put 2 pi. Instead of lambda, put 2 pi. 2 pi upon 2, we get pi here. And we get what? Instead of delta L, put delta phi, because it is phase difference. So we get phase difference is equal to n into 2 pi, integral multiple of 2 pi, or 2 into n, put 0, 0 pi, put 1, 1 into 2, 2 pi, put 2 here, 2 into 2, 4 pi, 0 pi, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. That means phase difference is even multiple of pi. So phase difference is either integral multiple of 2 pi. Phase difference, if either integral multiple of 2 pi or even multiple of pi where n starts from 0 plus or minus 1 plus or minus 2 plus or minus 3 dot dot dot. Point is bright. P point is bright, so called as constructive interference. Then condition for destructive interference. Remember well, delta L is nothing but the path difference. We have to discuss condition in terms of path difference at first. So delta L is equal to 2n minus 1 lambda by 2. You should remember this formula. Delta L is nothing but the path difference, which is equal to 2n minus 1 lambda by 2. And here n starts from 1, not 0. Remember well, dear students. Here n starts from 1 and not 0 when the formula is 2n minus 1 lambda by 2. Most important thing, when formula is 2n minus 1 lambda by 2, n starts from 1. But if the formula is 2n plus 1 lambda by 2, then n starts from 0. Most important thing. These things you should remember, you should keep in mind while solving various MCQs, while thinking about competitive examinations. So, if 2n minus 1 lambda by 2 is there, then it is starting from 1, n starting from 1. But if it is 2n plus 1 lambda by 2, then n starts from 0. So, what is this? Put n is equal to 1. 2 minus 1. We get 1 lambda by 2. Put n is equal to 2 here. 2 into 2, 4. 4 minus 1, 3 lambda by 2. Put n is equal to 3 here. 3 into 2, 6. 6 minus 1, 5 lambda by 2. That means what we get? We get what? 1 lambda by 2. 3 lambda by 2. 5 lambda by 2. 7 lambda by 2. 9 lambda by 2. In each and every condition we get odd multiple, and odd multiple and half the wavelength. Lambda by 2 is nothing but half the wavelength. So how we can state the condition for destructive interference? If a path difference between two light waves is odd multiple of half the wavelength, odd multiple of half the wavelength, point is dark, P point is dark, so called as destructive interference. Okay. Remember well, when delta L is equal to 2n minus 1 lambda by 2, at that time n starts from 1. But if it is delta L is equal to 2n plus 1 lambda by 2, if plus sign is there, then n starts from 0. This is the very much important thing that you should keep in mind. Then we have to state the condition in terms of phase difference. What I have already told you, instead of lambda put 2 pi. See here, instead of lambda put 2 pi. Instead of lambda put 2 pi. 2n minus 1 as it is. Instead of lambda we get 2 pi. 2 get cancelled and you will get what? 2n minus 1 into pi. Here 2n plus 1. 2n plus 1 into pi. Here plus sign should be there. Here plus sign should be there. Plus sign should be there. Here, sorry, here plus sign is there. Like this. Plus sign should be there. 2n minus 1 into pi. At that time n starts from 1. But if it is 2n plus 1 into pi, at that time n starts from 0. Similar to in case of path difference. Delta phi is equal to 2n plus 1 into pi. If plus sign is there, then it starts from 0. 2n minus 1 into pi, at that time n starts from 1. In both the cases, we get odd multiple. Odd multiple of what? Odd multiple of pi. So, if a phase difference between two waves is odd multiple of pi, at that time point is dark, P point is dark, and we get destructive interference. In this way, initially we have to find path difference between two waves, and if that path difference is integral multiple of wavelength lambda, n lambda, or odd multiple of half the wavelength, at that time we get condition for constructive interference. But if it is odd multiple of half the wavelength or odd multiple of pi, at that time we get destructive interference. So by referring this article, we will proceed further. Most of the remaining articles are very funny articles, very interesting articles. So be alert and remain in touch with my channel. Subscribe my channel, dear students, and watch this channel very carefully so as to make your physics very simple. Goodbye.